Hey, deep divers. Welcome back to the show. Before we get started today, don't forget to hit that like button, subscribe, and ring that notification bell so you won't miss out on any of our future dives. Today, we're taking a deep dive into a topic that's absolutely crucial for anyone interested in the environment, and especially for you, UPSC aspirants, who are gearing up for that GS3 paper.
Yeah.
We're diving deep into aquatic ecosystems, their classification, the major issues they're facing, and the conservation efforts that are underway. And hey, even if you're not prepping for exams, understanding this stuff is like key to appreciating our planet's incredible watery world.
Absolutely.
To help us navigate this underwater world, we've got an insightful expert with us today.
Hello.
They got this amazing talent for not just explaining the what, but also revealing the why, so you can really connect the dots and see that big picture. Ready to explore everything from those serene lakes tucked away in the Himalayas to bustling coral reefs teeming with life.
Absolutely. I think understanding these ecosystems is kind of like unlocking a secret code to how our planet functions.
Right. Let's break it down, starting with basics.
Okay. So first things first. How do we even categorize these aquatic ecosystems? I was reading through the material, and it seems like salt content plays a pretty big role.
Yeah, you're absolutely right. Salinity, or the amount of salts in the water, is a key factor. We broadly classify these ecosystems into freshwater, marine, and this fascinating in-between category called brackish water.
Brackish water.
Think of it like this. A delicate freshwater fish from like a pristine Himalayan lake wouldn't survive in the salty ocean, just like a saltwater fish wouldn't thrive in a freshwater pond.
So it's like different worlds existing within our planet's waters.
Exactly.
And our sources paint such vivid pictures of these ecosystems. We've got the vastness of oceans with their coral reefs, tranquil freshwater lakes, and then those unique estuaries where rivers meet the sea, creating this mix of fresh and salt water. Yeah, and each of these environments supports an incredible array of life. And it's not just about fish either. Think about all the microscopic organisms, plants, and even large mammals that call these ecosystems home. They're all categorized based on where they live and how they move.
I stumbled upon some really interesting terms in the research, like newiston. These are organisms that live right at the water's surface. Imagine tiny plants basking in the sunlight like they're on a tropical vacation.
Right.
And then there are the benthos, those creatures that live on the bottom like crabs scuttling along the seabed or worms burrowing in the mud. It's a whole different world down there.
Exactly. Each organism plays a crucial role, and they're all interconnected in this delicate balance. It's like this complex web of life. But here's where things get a little concerning. These aquatic ecosystems aren't as healthy as they should be.
All right, the sources really highlight the factors that can limit productivity. They point to sunlight, dissolved oxygen, water transparency, and temperature as key players. It's like having the perfect recipe for a thriving ecosystem, but if one ingredient is off, things can go wrong.
Precisely. And often it's human activities that disrupt this balance.
Yep.
Take dissolved oxygen, for example. Warm water holds less oxygen, so as temperatures rise due to climate change, aquatic life can struggle to breathe.
Yeah, the sources mentioned something called winter kill, which I found particularly fascinating and a bit alarming.
Oh, yeah.
Imagine a lake completely frozen over. No sunlight can penetrate, so photosynthesis stops. But the organisms living there still need oxygen.
Right.
In shallow lakes, this can lead to oxygen depletion, and fish can literally suffocate under the ice. It's a stark reminder of how delicate these ecosystems are.
It is, and it highlights the importance of understanding these systems so we can protect them. Now let's zoom in on a specific type of aquatic ecosystem lakes. They form through various geological processes and go through this intriguing aging process, accumulating nutrients and changing over time.
Speaking of lakes,
Yeah.
I was amazed to learn that here in India we have more artificial lakes than natural ones. Of course, we have stunning natural lakes in the Himalayas, and those formed by major rivers. But human interventions have also created numerous reservoirs and man-made lakes.
It's fascinating how we've shaped our landscape. And speaking of special lakes, there's one we can't miss. Aminpur Lake in Telangana. It's officially India's first biodiversity heritage site, boasting this incredible variety of plant and animal life.
Wow. It's like a treasure trove of biodiversity.
It is.
But sadly, not all lakes are as fortunate. Research delves into a serious problem: eutrophication.
Yeah.
It's like overfeeding a fish tank. Too many nutrients, often from agricultural runoff or sewage, cause excessive algae growth. These algal blooms block sunlight, and when they die and decompose, bacteria use up even more oxygen, essentially suffocating the lake.
Exactly, and it's a problem with serious consequences, not just for the ecosystem, but also for us humans.
Right.
Eutrophication can contaminate drinking water sources, make lakes unsuitable for recreation, and even impact industries that rely on healthy aquatic ecosystems.
So it's not just an environmental issue, it's an economic and social one too.
Exactly.
The good news is that the sources outline various strategies to combat eutrophication, from treating wastewater effectively to reducing fertilizer use in agriculture and implementing stricter regulations on industrial discharge. It seems like a multi-pronged approach is needed.
Absolutely. And it's important to understand the difference between point source and non-point source pollution. Think of it like this. A factory pipe dumping waste directly into a river is point source pollution. It's easier to identify and regulate. But non-point source pollution comes from diffuse sources like agricultural fields or urban runoff. It's like trying to fix 1,000 tiny leaks instead of one big one.
That makes sense. It sounds like addressing non-point source pollution requires a more holistic approach involving community education and sustainable land management practices. It's about changing behaviors and promoting responsible stewardship of our water resources. But let's move on to a particularly alarming type of algal bloom, harmful algal blooms, or HABs as they're called in the research.
Right.
These blooms are a major concern because they produce toxins that can poison fish, shellfish, and even marine mammals. In some cases, these toxins can become airborne, posing a risk to humans who breathe them in. Imagine enjoying a day at the beach and unknowingly inhaling toxic particles.
Right. That's a scary thought, but it's good to know that scientists are working on ways to monitor and predict HABs, giving us a fighting chance to minimize their impact. Now, shifting gears a bit, let's wade into the fascinating world of wetlands. They're like the in-between zones, where water and land meet, providing a whole host of ecological and economic benefits. Think marshes, swamps, and bogs, those soggy areas teeming with life. Wetlands are incredibly important. They act like natural filters, purifying water and trapping pollutants. They provide habitats for a vast array of plants and animals, and they play a crucial role in flood control, acting like giant sponges that absorb excess water. They even help mitigate climate change by storing carbon.
And did you know there's a whole day dedicated to celebrating wetlands? World Wetlands Day is celebrated every February 2nd to raise awareness about these often overlooked ecosystems.
It's true. The Ramsar Convention, a global treaty dedicated to wetland conservation, defines wetlands quite broadly. It includes areas of marsh peatland or water, whether natural or artificial, permanent or temporary, with water that is static or flowing fresh, brackish, or salt. It even includes areas of marine water that are less than 6 meters deep at low tide. Essentially, if it's wet and supports life adapted to wet conditions, it's probably a wetland.
That's quite a comprehensive definition. It highlights just how diverse these ecosystems are. Speaking of diversity, our research points out that India's 2017 wetland rules caused quite a stir regarding how we manage these crucial zones. The rules gave states more power to decide which activities are allowed in wetlands, raising concerns about potential conflicts between development and conservation.
It's a classic dilemma, balancing human needs with environmental protection. But there are efforts underway to find that balance. The National Plan for Conservation of Aquatic Ecosystems, or NPCA, is a great example.
Right. The NPCA, launched in 2015, brought together efforts to conserve both wetlands and lakes under one umbrella. That means a more coordinated and hopefully more effective approach to protecting these vital ecosystems. But how exactly do lakes and wetlands differ? They both involve water, but the research highlights some key distinctions.
Yeah. Lakes, as defined by the National Lake Conservation Plan, generally have a minimum depth of 3 meters. Wetlands, on the other hand, are shallower, usually less than 3 meters deep. Also, lakes often have a smaller pelagial ratio, meaning a smaller proportion of open water compared to the overall area. Wetlands tend to have more open water areas. Imagine a lake with a large central area of open water surrounded by a narrow ring of vegetation compared to a wetland with lots of channels and patches of open water interwoven with dense plant life.
So lakes tend to be deeper and have a smaller proportion of open water compared to wetlands. What about their role in purifying water?
That's another key difference. While lakes don't typically play a major role in filtering and purifying water, wetlands are like nature's kidneys. They trap sediments, absorb excess nutrients, and remove pollutants, playing a crucial role in maintaining water quality.
That makes sense. Wetlands are like nature's water treatment plants. But both lakes and wetlands face a myriad of challenges. The research outlines a whole laundry list of threats, from pollution and land use changes to overgrazing and deforestation. And of course, climate change is looming large, exacerbating many of these problems.
Right, which is why initiatives like the NPCA are so important. It aims to address these challenges head on, promoting sustainable land management practices, combating eutrophication, raising environmental awareness, and supporting afforestation and soil conservation efforts. It's a multifaceted approach, recognizing that protecting these ecosystems requires a holistic strategy. But let's zoom out a bit and talk about a global effort to conserve wetlands, the Ramsar Convention.
This sounds like a significant international agreement. What's the story behind it?
The Ramsar Convention, signed in 1971 in Ramsar, Iran, is unique in that it's the only global agreement focused specifically on a single ecosystem: wetlands. To be designated as a Ramsar site, a wetland must meet certain criteria. It might contain rare or unique wetland types, support significant populations of endangered species, or play a critical role in the ecological character of a region. It's like a global club for the most important wetlands.
That's pretty cool. And how is India doing when it comes to the Ramsar Convention?
India is actually a major player. As of December 2020, we have a whopping 42 Ramsar sites showcasing the incredible diversity and importance of our wetlands.
Wow.
And the list keeps growing. In recent years, we've added Asan Barrage in Uttarakhand Kanwar Tal, in Bihar Sur Sarovar, in Uttar Pradesh Lonar Lake in Maharashtra, and Sokar in Ladakh, each one a testament to India's commitment to protecting these valuable ecosystems.
That's impressive. But even with these conservation efforts, I imagine some Ramsar sites are still facing serious threats.
Unfortunately, you're right. There's a special register called the Montreux Record, which lists Ramsar sites experiencing or at risk of experiencing significant ecological changes due to human interference. It's like a watch list for wetlands in trouble.
And does India have any sites on this Montreux record?
Sadly, yes. India currently has 3 sites on the Montreux Record. Chilika Lake in Odisha was added in 1993 due to problems with siltation choking its mouth. But thanks to successful conservation efforts, it was removed in 2002. That's a real conservation success story.
That's encouraging to hear. What about the other 2 sites?
As of 2020, Loktak Lake in Manipur and Kyoto National Park in Rajasthan remain on the Montreux Record. Loktak Lake is facing issues with deforestation and pollution, while Kyoto National Park is struggling with water shortages and unsustainable grazing practices. It's a reminder that designating a site is just the first step. Ongoing management and protection are crucial to ensure these ecosystems continue to thrive.
It's a constant battle to balance human needs with the needs of the environment. We've covered a lot of ground today, from tranquil lakes to dynamic wetlands, and we've learned about some serious challenges facing these ecosystems.
We have.
But our journey doesn't end here. We'll be back soon to dive into some other fascinating aquatic ecosystems like estuaries and mangroves and explore the wonders and threats they face.
Stay tuned, folks. There's a whole underwater world waiting to be explored. Welcome back, deep divers. Last time we explored lakes and wetlands, but our aquatic adventure continues. Today we're venturing into the fascinating world of estuaries, those bustling zones where rivers meet the sea.
I've always been intrigued by estuaries. They seem like such dynamic environments, a constant push and pull between freshwater and saltwater. What exactly makes an estuary an estuary?
Imagine a place where the river's flow gradually merges with the ocean's tides, creating this unique gradient of salinity. This mixing zone is in constant flux, influenced by the ebb and flow of tides, making estuaries incredibly dynamic and productive ecosystems.
So it's not just a simple meeting point, it's a zone of transition. Our sources mention that specific conditions need to align for an estuary to form. Rising sea levels, the movement of sand and sandbars, even glacial and tectonic processes can all contribute to shaping these coastal environments. It's fascinating how these forces shape our planet.
Indeed, and despite the challenges of fluctuating salinity and tidal variations, estuaries are teeming with life. They act as natural filters, trapping sediments and nutrients from rivers before they reach the open ocean. This abundance of nutrients fuels a remarkable diversity of life, from microscopic plankton to large fish and wading birds.
It's like a biological melting pot. The sources describe some key characteristics of estuaries. They're typically semi-enclosed, connected to the open sea, and experience relatively calm waters compared to the open ocean. And the salinity can change dramatically from almost freshwater near the river mouth to full-blown ocean salinity further out. It makes you wonder how organisms adapt to such drastic changes.
They've evolved some remarkable adaptations. Some species can tolerate a wide range of salinity, while others migrate in and out of estuaries with the tides following their preferred salinity levels. And it's not just about the creatures living in the water. Estuaries also support a rich diversity of plant life, including salt marshes and mangroves, which provide crucial habitats and protect shorelines from erosion.
It's amazing how life finds a way to thrive even in challenging conditions. But as we discussed earlier, human activities often disrupt this delicate balance. What are some of the major threats facing estuaries?
Sadly, estuaries are under pressure from various human activities. Pollution from industrial and agricultural runoff is a major concern. Excess nutrients can lead to eutrophication, just like in lakes, causing harmful algal blooms and depleting oxygen levels. We also see problems with unsustainable tourism practices, increased dredging and shipping traffic, and habitat destruction due to coastal development.
It's disheartening to see how our actions can have such negative consequences. And then there's climate change adding another layer of stress to these ecosystems. Rising sea levels can inundate and erode estuarine habitats, and changes in precipitation patterns can alter the balance of fresh water and salt water, disrupting the delicate salinity gradient that defines these environments.
Exactly. The cumulative impact of these threats can be devastating. We're seeing declines in fish and shellfish populations, loss of biodiversity, and degradation of water quality in estuaries around the world.
It's a reminder that we need to change our approach, move towards more sustainable practices, and prioritize the health of these vital ecosystems. But are there any positive developments? Are there efforts underway to protect and restore estuaries?
Absolutely. There's growing recognition of the importance of estuaries, both ecologically and economically. Many countries are implementing conservation and management strategies, including establishing marine protected areas, reducing pollution from land-based sources, promoting sustainable fishing practices, and restoring degraded habitats.
That's encouraging to hear. What about India? Our sources mention that India, with its vast coastline and numerous rivers, has an abundance of estuaries, particularly along the Bay of Bengal. Are there any specific initiatives focused on protecting these vital ecosystems?
Yes, India has been actively involved in efforts to conserve and manage its estuaries. There are several government programs and research initiatives focused on understanding the ecological dynamics of these ecosystems, assessing the impacts of human activities, and developing sustainable management plans. For example, the National Coastal Zone Management Authority, NCZMA, plays a crucial role in regulating development activities along the coast, including in and around estuaries, to minimize environmental damage.
That's good to know. It sounds like there's a growing awareness of the need to protect these valuable ecosystems. But shifting gears a bit, let's explore another fascinating coastal ecosystem that's often associated with estuaries: mangroves. I've always been amazed by how these trees can thrive in salt water.
Mangroves are truly remarkable. They've evolved some fascinating adaptations to cope with the harsh conditions of salty, waterlogged environments. For example, they have special roots called pneumatophores that stick up out of the mud, allowing them to breathe even when submerged by tides.
It's like they're snorkeling. And the sources mention that mangroves have other tricks up their sleeves. Some species excrete excess salt through their leaves, while others block salt absorption at their roots. It's amazing how they found ways to survive and thrive in such a challenging environment.
And their resilience is crucial, not just for the mangroves themselves, but also for the entire coastal ecosystem. Mangrove forests provide a wealth of ecological and economic benefits. They act as natural barriers protecting coastlines from erosion and buffering against storm surges.
They're like nature's first line of defense against the power of the sea. The research also highlights their role as nurseries for countless fish and shellfish species, supporting healthy populations that sustain both marine ecosystems and human livelihoods. They're also biodiversity hotspots, providing habitats for a remarkable array of birds, reptiles, mammals, and invertebrates.
Exactly, and let's not forget their role in mitigating climate change. Mangroves are incredibly efficient at storing carbon, helping to regulate our planet's climate. But despite their importance, mangrove forests around the world are facing increasing threats primarily from human activities. Deforestation for timber and charcoal production, conversion of mangrove areas for aquaculture, and agricultural pollution from industrial and urban sources, and the impacts of climate change are all taking a toll on these valuable ecosystems.
It's a reminder that even the most resilient ecosystems can be pushed to their limits. But are there any bright spots? Are there any success stories in mangrove conservation?
Absolutely. There's growing recognition of the importance of protecting mangroves, and efforts are underway to restore degraded mangrove forests, promote sustainable management practices, and raise awareness about the crucial role these ecosystems play in coastal protection and biodiversity conservation. In fact, India has a shining example: the Sundarbans.
Oh yes, I've always wanted to visit the Sundarbans. It's a UNESCO World Heritage Site, right? I've heard it's home to the Royal Bengal tiger and an incredible array of other wildlife.
You're right. The Sundarbans, located in the delta region of the Ganges, Brahmaputra, and Meghna rivers in the Bay of Bengal, is the largest mangrove forest in the world. It's a testament to the power of conservation efforts and the importance of protecting these unique and valuable ecosystems. And India has other impressive mangrove ecosystems too. The Bhitarkanika mangroves in Odisha are the second largest in the Indian subcontinent, and there are significant mangrove forests along the Godavari-Krishna deltaic regions of Andhra Pradesh, the Gulf of Kutch and Kori Creek in Gujarat, and the Andaman and Nicobar Islands.
It's incredible to think that India is home to such biodiversity both on land and in its coastal waters.
Okay.
But now let's shift our focus to another fascinating and threatened ecosystem.
Coral reefs. I've always been mesmerized by their vibrant colors and the sheer diversity of life they harbor. Coral reefs are truly spectacular. Often called the rainforests of the sea, they're built by tiny animals called coral polyps that secrete calcium carbonate skeletons. These skeletons form the foundation of these complex and colorful underwater structures.
So it's like a city built by tiny animals. But there's more to the story, right? Our sources mention a symbiotic relationship between coral polyps and algae called zooxanthellae.
Exactly. It's a fascinating partnership. The zooxanthellae live within the tissues of coral polyps, providing them with food through photosynthesis. In return, the coral polyps provide the zooxanthellae with a safe haven and access to sunlight. And as a bonus, the zooxanthellae give the corals their vibrant colors.
It's a mutually beneficial relationship, but it's also quite delicate. We've all heard about coral bleaching, which is a major threat to reefs worldwide.
You're right. Coral bleaching occurs when the symbiotic relationship between coral polyps and zooxanthellae breaks down, often due to environmental stress. When corals bleach, they lose their vibrant colors and become more susceptible to disease and death.
And the primary culprit for this stress is rising ocean temperatures linked to climate change.
Climate change is a major factor, but it's not the only one. Pollution from land-based sources, overfishing, destructive fishing practices like dynamite fishing, and even careless tourism activities can damage and degrade these fragile ecosystems.
It's a sobering reminder of the interconnectedness of our planet's systems and the far-reaching impacts of human activities. But amidst these challenges, there's hope. Scientists, conservationists, and communities around the world are working tirelessly to protect and restore coral reefs.
Absolutely. They're implementing marine protected areas, promoting sustainable fishing practices, reducing pollution, and even experimenting with innovative techniques like coral gardening and assisted evolution to help corals adapt to changing conditions.
It's a race against time, but one we can't afford to lose. Coral reefs are not just beautiful and biodiverse. They provide numerous benefits to humans, from supporting fisheries and tourism to protecting coastlines from erosion and even offering potential sources of new medicines.
They're a vital part of our planet's life support system, and their fate is intertwined with our own. So as we wrap up this part of our deep dive into aquatic ecosystems, let's remember the interconnectedness of these precious environments and the urgent need to protect them for future generations.
Welcome back, deep divers. We're continuing our exploration of that incredible underwater world of coral reefs. Last time we talked about their importance, their symbiotic relationship with algae, and the threats they face, especially from coral bleaching. But there's so much more to discover about these amazing ecosystems. For instance, did you know that there are different types of coral reefs?
That's right. Not all coral reefs are created equal. We can classify them into several types based on their structure and location relative to land. There are fringing reefs, which grow close to the shoreline, almost like a fringe along the coast. Then there are barrier reefs, which are separated from the mainland by a lagoon, forming a barrier between the open ocean and the calmer waters behind the reef.
And then there are atolls, which I find particularly fascinating. These are ring-shaped reefs that encircle a lagoon, often rising from deep water far from any landmass. How do these different types of reefs form? It seems like they would require very specific conditions.
You're absolutely right. The formation of each reef type is influenced by factors like sea level changes, geological processes, and the growth patterns of the coral itself. For example, fringing reefs often develop along the edges of volcanic islands as the island subsides or sea levels rise. Barrier reefs can form when fringing reefs grow upward as the landmass they surround sinks, creating a lagoon between the reef and the shore. And atolls typically form around submerged volcanic islands, with the coral growing upward as the island slowly sinks below sea level.
It's amazing how these processes over vast stretches of time shaped these incredible underwater landscapes. And it's not just their structure that's fascinating. The research mentions that India boasts a remarkable diversity of coral reefs, too.
Indeed. We see fringing reefs along the coastlines of the Andaman and Nicobar Islands, patch reefs in the Gulf of Mannar and the Gulf of Kash, and both barrier reefs and atolls in the Lakshadweep Islands. Each of these locations harbors a unique array of coral species and associated marine life.
It's like having a treasure trove of underwater biodiversity right here in India.
Yeah.
But beyond their beauty and ecological importance, coral reefs also provide a wealth of benefits to humans. We touched on this earlier, but can you elaborate on how coral reefs support our well-being?
Coral reefs are essential for coastal protection. Their complex structures help dissipate wave energy, reducing erosion and buffering coastlines from storm surges. They support fisheries by providing habitats and breeding grounds for countless fish and shellfish species, which are a vital source of food and income for millions of people worldwide, and they attract tourists from around the globe, contributing significantly to local economies. So they're not just beautiful and biodiverse, they're also incredibly valuable for our economies and well-being. But we know that coral reefs are facing numerous threats. Coral bleaching is a major concern, and our sources point out that it's not just rising temperatures that are to blame. Several other factors can contribute to this phenomenon.
That's right. Extreme low or high temperatures, intense solar radiation, sudden exposure to air during very low tides, sedimentation from runoff, and even freshwater dilution from storms and floods can all stress corals and disrupt their symbiotic relationship with algae, leading to bleaching.
It's like a perfect storm of stressors converging on these delicate ecosystems. And then there are the human-induced factors we discussed earlier. Pollution from agricultural runoff, sewage discharge, and industrial activities, along with destructive fishing practices and unsustainable coastal development.
It's a complex web of interconnected challenges, and addressing them requires a holistic approach. Fortunately, there's growing awareness of the importance of protecting coral reefs, and efforts are underway around the world to address these threats. That's encouraging to hear. What are some of the key strategies being employed to conserve and restore coral reefs?
Many countries are establishing marine protected areas to safeguard critical reef habitats and regulate human activities within these zones. Efforts are being made to reduce pollution from land-based sources by improving wastewater treatment, promoting sustainable agricultural practices, and strengthening regulations on industrial discharge.
And what about the fishing industry? Overfishing and destructive fishing practices can significantly impact coral reefs.
You're right. Sustainable fishing practices are crucial for maintaining healthy reef ecosystems. This includes setting catch limits, establishing fishing seasons, and promoting fishing methods that minimize damage to coral habitats. There are also initiatives to combat illegal and destructive fishing practices such as dynamite fishing, which can cause widespread damage to roofs.
It sounds like a multifaceted approach is needed involving governments, scientists, communities, and the fishing industry working together to ensure the long-term health of coral reefs.
Exactly. And beyond these direct management strategies, there's also growing interest in exploring innovative approaches to help corals adapt to changing conditions. For example, scientists are experimenting with coral gardening and assisted evolution techniques, selectively breeding corals that show greater tolerance to stress, or transplanting corals from warmer waters to reefs that are experiencing bleaching events.
That's fascinating. It sounds like there's a lot of hope and innovation in the field of coral reef conservation. It's inspiring to see people working so hard to protect these incredible ecosystems. But as we wrap up this deep dive into the world of aquatic ecosystems, I think it's important to step back and reflect on what we've learned. We've explored a remarkable diversity of life, from microscopic plankton to majestic whales, from tranquil lakes to bustling estuaries and vibrant coral reefs. We've delved into the intricate web of relationships that connect these organisms and the physical environment they inhabit.
And we've learned about the serious challenges facing these ecosystems, from pollution and habitat destruction to climate change and overexploitation. But we've also highlighted the resilience of nature and the inspiring efforts underway to conserve and restore these vital ecosystems.
It's been a journey of discovery, reminding us that we're all connected to these aquatic ecosystems, whether we live near the coast or far inland. Their fate is ultimately intertwined with our own.
Absolutely. We depend on these ecosystems for food, clean water, climate regulation, and countless other benefits. Protecting them isn't just about conservation, it's about safeguarding our own future.
So as we resurface from this deep dive, let's remember the key takeaways. These aquatic ecosystems are incredibly diverse, valuable, and interconnected. They face serious threats, but there's hope if we act decisively and collaboratively. The future of these ecosystems, and indeed our own well-being, depends on the choices we make today. So until next time, don't forget to like, subscribe, and hit that notification bell so you won't miss our future deep dives into the fascinating world around us.
Keep learning, keep exploring, and keep diving deep.